Well, what we have is it's called our HIM mixer. It stands for high intensity mixer. And what our philosophy is instead of moving towards larger and larger blenders that have a very difficult job trying to apply coatings or micronutrients or powders, we're going to the opposite direction. Our idea is to have much more precise blends, precise mixes in a smaller batch. So the way our mixer works is it has about a 30-second blend time and about a 2-second discharge time. So what we can do with a 1 2-ton mixer is what we used to do with two 12-ton mixers. So we have a lot more efficient mix. We have the same output. We just do it with several small batches, much more precise, much faster, much less power consumption. The technology came about 20 years ago. A lot of customers need for very precise blending and bagging systems internationally. So we developed a mixer, licensed the technology out of the food industry that allows very precise batches and also a quick discharge to minimize any segregation in your blend because everything was being bagged. We've developed that technology over the past years to be able to apply different micronutrients and do different coating technologies. And so now we see this mixer having huge advantages in the blending industry in the U.S., offer flexibility for doing coatings, blending, or wholesale. This is our lab unit here. This is a 100-pound batch unit. So we have 100 pound of urea in here. We already did a batch earlier. We treated this with a Wolf Track powder micronutrient and a polymer coating. So we have a control release micronutrient coated urea in here now. We're going to add another layer of a polymer for second stage control release with a dye in it, just so we can see the distribution of this polymer in the mixture and then the time. So we'll get this running in a minute. You can see that the whole blend will be fluidized. Every granule in there is in constant motion, and the mixture will distribute this thing. So we're gonna the full scale model will have spray nozzles during the fluidizing zone for the application. We'll do just a pour here as a worst case test. The almost instantaneous discharge, thereby minimizing the time for the blend cycle. So you have about a 15-second blend cycle, 2-second discharge time. So you can make very high capacities with a small blender. See the even distribution of the polymer. It's one of the critical parts is to have all granules totally encapsulated and have the exact amount of the polymer on each granule. So whether you're doing micronutrients or just bulk blending or adding liquids impregnation, you're going to get 100% even distribution of that liquid on all the granules in the blend.